So I have a bottle of cobalt metal.
You
You can't really read it. I wonder if this camera is not working so great. Can you see it? You can't really see it either. Huh?
look at the screen. Yeah.
All right. Can you see it there?
Yes.
Okay. It's a little bit, it just looks like a gray. It's been powdered or pulverized, but it looks like a gray metal. It could have some oxidation on there. And so we're going to take some cobalt metal and react it with what? Hydrochloric acid. So let me get my hydrochloric acid here. There's a 6 molar. And so I'm just going to drop in some hydrochloric. I'm not going to be very careful. Can you see it better here or through here?
Probably better if you send it. I mean, I can see it, yeah.
Okay, let's go for it then. So what did you predict happens here? Did you predict reaction or no reaction?
Reaction.
I see reaction occurring. What do you see happening?
Is it both forming?
Yeah. Can you see the bubbles forming?
No.
I'm going to zoom in here. And focus it.
Oh, I see it. Yeah, I see it flying.
Oh, yes.
There are bubbles. It's bubbles forming CCG. You can see it down. Look at the very bottom. And so we got bubbles of clear colorless gas. That gas is hydrogen gas. And we're forming a solution of what? Cobalt chloride. Cobalt actually has a color to it. It's too hard to see here. Let me see if I put a white background on this, if we could see it better. No.
Okay, it works.
Black.
Kind of blue. Yeah. It's actually purple. Can you see it? Here. Try it one more time.
I feel like it's on some weird setting.
See.
Well,
Oh well, actually here. Can you see it now? It's blue.
oh,
Yeah.
oh, yeah, I see it now.
Purple blue.
Black. Oh, wow. Good, that's not what
So what's causing that blue color? Blue purple color. Is it the chloride ions or is it the cobalt ion? It's the cobalt. Cobalt 2 plus AQ is purple or blue. All right. Next reaction we're going to do is cobalt with copper 2 nitrate. All right, take a look at copper 2 nitrate. What color? It's blue. But what's causing the blue color? Do you think it's the copper ions or the nitrate ions or both? Well, it turns out it's the copper ions. The nitrate ions are colorless. The copper 2 ions. So copper 2 nitrate solution is blue. Okay, let's go ahead and do this, although I don't think we're going to see much here, but we'll try it anyway. This is probably easiest if you guys did this.
Oh, it's turning green.
Well, what happened to the blue color? It disappeared completely. Now that blue color disappeared and I got a kind of a black precipitate. And now it's being replaced. The blue color is being replaced by a red pink color. Or kind of a purple color. Yeah. And then there's a black precipitate on the bottom. Yeah, it's kind of like blood or blue blood. And so what's causing that, it's a light purple color. What's causing that light purple color? Cobalt. Okay, what's the next reaction? And what's the black precipitate? What do you think that black precipitate is? Copper metal. Yeah. It's a nice thick black precipitate on the bottom. The cobalt metals disappeared, the gray was replaced by black precipitate.
The next reaction is copper and hydrochloric acid.
Copper and hydrochloric acid?
Yeah. Copper solid, that is.
So here you can see the color of the copper. So I'm just going to take a strip of copper metal. It's this orange metal, brown orange metal. Has the shiny luster to it. And what does hydrochloric acid look like? How would you describe it? CC, well, L would be a liquid, which is correct, but if we did CCS, it's a solution. Yeah, this is it. And so what did you predict happens with this?
You're going to get hydrogen gas and then copper chloride.
Yeah.
Alright, so
You know what? I got a very shiny piece of copper.
yeah.
In fact, let me just I got a shiny piece of copper. A reaction does occur, but not the reaction that we're thinking. Let me just say. Look at new pennies are shiny. The old pennies are either going to be kind of brown or black. And so old pennies are going to have what we call an oxide coating on the surface of the metal. And what's happening is the HCl is eating up the oxide by a double replacement reaction. Here. And so if we're looking at the brown copper 1 oxide, it's going to form copper 1 chloride, 2 of those, plus water, H2O liquid. The driving force would be going from stronger acid to weaker acid. If we're looking at black coating of copper 2 oxide, then the same thing. The HCl will eat it up. It's going to form copper 2 chloride plus water. And so again, the driving force here is stronger acid to weaker acid. And so now my piece of copper is extremely shiny, you know. Compare the color there.
Yeah.
So just took off the oxide coating as a double replacement reaction.
Still shinier as each time.
But that's not necessarily the reaction we're after. What was the reaction we're after? We're after the reaction of hydrogen gas formation. That is the acid eating up the copper metal. Did the acid eat up the copper metal? No. So we got no reaction here. No reaction. It did eat up the oxide coating, but not the metal. And no, that's because there's no driving force for that particular one. Okay, what's the next reaction? copper metal with
Cobalt nitrate.
cobalt nitrate. Well, let's first look at what cobalt. What color is cobalt? It's a kind of red color, red, pink, purple. Depends on how concentrated it is. The more concentrated it is, the more purple or blue appears. So this is not super concentrated. This is 0.1 molar. Colors are always deceptive. You know, what color is it? It's hard to describe sometimes. And so I have some of this pink copper too. Did you expect a reaction or no reaction to occur here?
No reaction.
And so I'll just get a strip of copper and drop it in here. Let's take a look. Well, I actually can't see anything here, but sometimes reactions are sluggish, you know, and especially if you have an oxide coating on there, it could be sluggish. And so normally we give it some time. And so we'll come back to it, but I don't see anything happening to it. But let's check it again after a few minutes. Okay, then after that we go to what?
Silver nitrate.
Copper plus silver nitrate. Now silver nitrate I got to be careful with, otherwise what might happen? Yeah. My fingers will turn black because silver ions are powerful. Silver ions are powerful. Oxidizer. There's silver nitrate stored in a brown bottle like this. Normally when we have brown bottles like this is for light sensitive. Silver turns out to be light sensitive as well. But let's take a look at the color of silver nitrate. Can you see the color? CCS. CCS because there's the solute, silver nitrate, which is a white solid dissolved in water. CCS. You also have to watch out because sometimes people spill silver nitrate on the outside of this and you grab it, even though Okay, did you predict reaction for this one?
Yes.
Alright, so I'm going to take my strip of copper and then just drop it in here. Let's see what happens. Alright, let's watch this. Do you see the black precipitate forming on the surface of the copper? What do you think that black precipitate is?
Silver.
Silver metal. Tiny crystals of silver metal. There's a black coating on there. It's kind of forming like a little fur of precipitate. As the crystals grow bigger, then they're going to look not black, but they're going to look more gray. And they're going to give us silver color. It's hard to see, but the solution is starting to turn what color? What color do you predict the solution will start to turn?
Or, well, it's still clear.
It's still clear, but give it some time. In a couple of minutes, the solution will start to turn what color?
Will it turn the same colors as silver?
Well, what's in solution at this point? Let's look at your...
Copper nitrate.
Oh, will it turn blue?
It's going to turn blue. Well, if it gets concentrated enough, it's kind of hard to see right now, but we predict. I'm going to come back to this one. We'll see if the blue color develops. But we expect it to turn blue because of what ions? All right, after copper with silver nitrate, we move on to
Copper with zinc nitrate.
copper with zinc nitrate. And so let's get the zinc nitrate. Zinc nitrate is a CCS. Zinc ions are colorless, nitrate ions are colorless. Zinc nitrate CCS. I'll take a piece of copper, I'm going to drop that in there. What do you predict for this one?
No reaction.
No reaction, yeah. That's correct. No reaction is predicted. But just to be sure, we'll give it some time. And so initially, nothing's happening. But maybe I didn't give it long enough to react. You know, some reactions are sluggish. So let's go back to the copper with the cobalt. We go back to the copper with the cobalt, and it looks exactly the same as before. Pretty much nothing. Nothing's happened. Yeah. All right, what's next?
Copper and nitric acid.
Copper and nitric acid. Why didn't they give me enough test tubes? I didn't get enough. For this one, I should do this one in the hood. Do you know why?
Because something's going to happen.
Yeah, something's going to happen.
That's going to explode.
Well,
I'm just kidding.
it's not going to explode, but I got to watch out because nitric acid is a powerful or a strong oxidizer. Yeah. And so nitric acid, when you look at it, what is it? CCS. Well, let me just do that in the photo with you. What do you predict forms here?
Copper ions. Nitrous oxide. Water, carbon ions, and nitrogen oxide.
Yeah. Well, I'll just expose myself to a little bit of. Do you see the blue color?
Yeah.
Do you see the bubbles?
Oh yeah, I do.
Now do you see the bubbles?
Yes.
That's the
Yeah, that's a gap. Oh, now you can see it's turning pretty blue, right? Here, I'm gonna just plug it with my fingers. We'll expose. We'll sacrifice them. But initially, it's clear colorless gas forms. That clear colorless gas is what is that clear colorless gas that forms? Actually, let's just get a cord.
Yeah, but that would be more.
That clear colorless gas is slowly turning orange. Do you see the orange gas there? And do I have a stopper? I don't have a stopper, shoot, but I should grab one. That orange gas, okay, the clear colorless gas was NO. Do you see how rapid the bubble formation is here?
Yeah.
Yeah.
Let me see if I have a phone.
I don't want to stopper too tight because I might get, yeah. But it's, some people will say this is a beautiful orange smoke. The beautiful orange smoke is, you know what that is? I have beautiful orange smoke here, but do you remember the Grand Camp? The Grand Camp?
Oh, that was like that big fire and people were describing that.
It was a ship.
Yeah.
The ship that caught on fire.
Yeah.
The ship that caught on fire and was giving off beautiful orange smoke that a lot of spectators came to see, right? Well, that beautiful orange smoke, the guy said there's a real sulfur smelling odor in the air. Do you remember that from the video? Well, it isn't. It's a real nitrogen, NOx odor, very characteristic of. So NO gas is formed. This is a CCG. And then with time, the NO gas reacts with oxygen in the air. To form NO2 gas. This is the orange gas. Both NO gas and NO2 gas are toxic, right? So we don't. Both are components of smog, so when you see a brown layer of smog, it's NO2, oxides of nitrogen. And so, air used to be a lot smoggier in LA, so I know that odor. That odor is that odor you get when there's photochemical smog in the air. It burns your eyes, kind of thing. And so it doesn't form hydrogen gas, it forms nitrogen monoxide, which gets converted into nitrogen dioxide. Or nitric oxide, which gets converted into nitrogen dioxide. Okay, what's next?
Zinc and hydrochloric acid.
Zinc and hydrochloric acid. Zinc is a nice gray metal here. Silver. See it so well. This is it here. So I'll get a piece of zinc here. Let's see. Can you see it? All right, and then the hydrochloric acid is a CCS, and what do you get? Yeah, this one I'm not going to do in the hood because hydrogen gas, even though it's a strong reducer, it's not that toxic. So I don't care if I inhale hydrogen gas fumes. You see the effervescence?
Yes.
And hydrogen's a CCG. And then you guys did something. Remember you did this reaction, I think, before with magnesium. Is that right? Yeah, this is generating a lot of gas. So we'll light the gas on fire, or try to. You got to watch out because we don't want any explosions, so you don't do this in a closed container. That's a lot of hydrogen that's generated. Okay. That's it. But do you want to see this? Should I pass it around? Or, all right, let's just look. Well, zinc, is zinc a good reducer? What do you think? Yeah, zinc is a lot of hydrogen gas. Zinc is. In fact, zinc is a great reducer. The reaction is going to go until the limiting reagent is eaten up. I don't know which one's the limiting reagent. It could be the hydrochloric acid or it could be the zinc. And so either I'm going to eat up all the zinc or I'm going to consume all the hydrochloric acid. When I consume the hydrochloric acid, the liquid's still there. It's just, it's gone flat. completely. No more HCl. And so it'll probably go for another 5 or 10 minutes or something, and then stop. We'll just let it go. We'll take a look at it again later. But it is generating a lot of hydrogen gas. I mean, let's see. You can test for hydrogen gas pretty easily because obviously you don't want to use this as the test for hydrogen gas because it can cause explosions.
If there was enough hydrogen gas, like if there was more, would it cause like an actual explosion rather than just a little noise?
Did I do the hydrogen balloon? I didn't do hydrogen? All right, let me pause it here.
Oh, I think you did.
Do you guys remember I did it in the hood over there?
Yeah, I remember. Oh, okay.
Was that, what would you call that, explosive or this little pop?
I mean, the balloon popped, but it was an explosion.
Was it an explosion? Or just popped balloon?
What does I think explosion? I think it's like.
Well, okay, I'll do it again. It won't take very long since we don't have that much. How many more reactions do we have?
I think 3.
Yeah, then we have time. You guys want to see the hydrogen?
Yeah.
Yeah, all right.